Alrighty, welcome back, computer science students. This is another video on interfaces. Our last one talking about the comparable interface specifically. Sorting is just so common and so prevalent in Java that we need to talk about all these different ways to sort. And we sort by implementing the comparable interface and defining how we're going to sort. So we talked about like three different ways to sort based on ID. We could do ascending, we could do descending, both using conditionals. So we had this whole conditional setup. If my ID is less than yours, return a negative number. If my ID is greater than yours, return a positive number, else return 0. Turns out when it comes to integers, if you just return some math, return ID minus p dot get ID, it'll work out to do the same thing. Negative numbers when mine's less than yours, positive numbers when mine's greater than yours, and 0 when they're the same. And so it kind of works out the same. But this logic, if, else, if return -1, else if return 1, else return 0, it does show up. And in particular, when it's not an integer that we're comparing by, this is going to be really useful. So I'm going to start here. And we're going to talk about sorting by first name or last name. So right now, this sort method depends on our compare to. Our compare to depends on ID. So what if we want to sort by like last name? Or first name, or potentially first name then last name, if they're the same. So we're gonna have to get a little creative here to do that last bit, but we're gonna try to fit it all in this video. All right. So, all right. So how do we compare strings? This has all been talking about comparing ints. How do we compare strings? So again, the structure is going to be the same. Under some condition, I'm going to be to your left. Under some other condition, I'm going to be to your right. And under another condition, we're going to be the same. So let's compare by first name, or let's do last name. No, we'll do first name. We'll do first name. We'll do last name next. So we'll do first name. This would be my first name, right? So if my first name is less than your first name, but what does it mean? I guess I could do get first name. But what does it mean to be less than when we're talking about strings? If we try this, we're going to get an error. So it's undefined for argument type java.lang.string. So we can't compare strings with a less than sign. We really want to do alphabetical, right? So we could try to write something like if first name dot char at 0, the first letter in my first name, is less than the first letter in your first name, p dot get first name dot char at 0, right? So if my first name starts with I don't know, an M, and your first name starts with an N, then I would come before you, and we could write this. You can actually compare characters like this, but then you also have to worry about character at 1 and character at 2 and character at 3 and character at 4. And how far can you actually go? You can write some complicated loops to make this happen, but again, it feels like someone has probably tried to compare strings before and written methods for it, and we should probably be able to use that. So let's jump over here and let's look at the string class. Let's real quickly Java string class. Let's see if somebody's done our work for us. All right, so we have our string class. Ooh, look at that. All implemented interface. String has implemented comparable. That means there's already a way built in to compare strings. So there should be a compare to method in here. Let's scroll down a little bit. Yep, look at that. Compare to is in there because it has to be. So let's look at the compare to method. Compares two strings lexicographically based on Unicode value of each character in the strings. Blah, 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 blah. Ooh, we could do, it compares strings with minuses, kind of like we did with integers in our last example in the last video. The important part is, string class has a compare to method, and it returns a positive number if it should be to the right, negative number if it should be to the left, and 0 if they're the same. So, what if we do first name dot compare to p dot get first name? Well, if I get my parentheses right, which I'm not doing a good job of, what do we have? What's there? Oh, right. Cannot convert int to Boolean. So if I compare first name to my first name to his first name, if that's less than 0, right, compare to always returns an integer. Negative if it's left, and positive if it's to the right, and 0 if they're the same. So if I compare my name to his name, or their name, my name to your name, and I get a negative number, then I can just return a negative number. I can do an else if first name dot compare to p dot get first name is greater than 0, then I can return a number that's greater than 0. And I think my parentheses are off again here. Maybe. No, they actually look okay. Oh, no they don't. I have one in the wrong spot. This should be here. There we go. So I need to compare to the first name of the other person. If it's greater than 0, I return a positive number. If it is 0, I return 0. So now we're doing a comparison using the string compare to method. I don't actually know all the details about how it works. I have a pretty good idea, but I don't know. But I do know that it exists, and it does what we want. So now we have sorted by first name. Kala, David, Jeff, Jonathan, Kate. Cool. You may have, if you're truly a really good observant student here, you may have realized there actually is a way to shorten the string comparison like we did with the integer comparison. We're doing a first name dot compare to get first name is less than 0, we return a negative number. If it's greater than 0, return a positive number, else return 0. Well, in theory, we could just return first name dot compare to p dot get first name. Well, if it's negative, we want to return negative. If it's positive, we return positive. If it's 0, return 0. So this does the same thing. So we're just basically saying, yeah, with my person, I want to sort it based on the string compare to method that compares my first name to their first name. And if the string comparison method says that I should be before them, then I should be before them, right? And for last name, you can do last name dot compare to b dot get last name. And now we can sort by last name. But we're going to see really quickly, and this is the last problem I want to handle. If we sort by last name, we have two Williamses. We have a David Williams and a Calla Williams. And it turns out that based on this sorting, if we sort by last name, we actually get David Williams before Calla Williams, or Kayla Williams. And so the question is, how can I sort if if our last names are the same, then sort by first name. That's what I want to do. So what I can do is say if last names are the same, if last name dot compare to p dot get last name equals 0, if our last names are the same, then return first name dot compare to p dot get first name. Else return last name dot compare to p dot get last name. So now if we follow the logic here, if my last name is the same as yours, then compare our first names and sort based on first name. Otherwise, sort based on last name. So if we just add a little extra logic, and we kind of walk through this and see it, then we'll see that we can sort by last name first and then first name, or first name first and then last name, or however we really want to sort. We just add really good logic in here. And as long as we write it correctly and we understand what compare to does and how it operates, you can sort however you want. And so that can work with strings, and you can sort you can make really complicated sorting algorithms that sorts by last name, then first name, and then if the last name and the first name are the same, then it sorts by ID or something. You can make really good ways of sorting things just by adding extra logic in our compare to method. But at the end of the day, all we need to know is, how should I know whether I come before or after my neighbor? And as long as we can define that and say negative number means before, positive number means after, 0 means we're the same, then we can sort. And so that's it. So that's the whole discussion for implementing comparable. Just remember, you have to do implements comparable, the thing you want to compare to, and then you have to do public int compare to, and then write the logic for it. So this is just something you have to memorize for now or refer back to for now. But as you get more practice with it, you'll understand it a little better. And we'll be able to dive in there. And you should be able to write this on your own. So the next couple videos here are going to talk about writing our own interfaces and why we might want to do that and what they would look like. So I will see you guys next time.